We live? We live? Hey, we are live, ladies and gentlemen. We are back. Let me see my. Oh, okay. Okay. Oh, I bet. I know you say you didn't. I know you say you didn't want my opinion, but the audio sounds good. Oh, okay, okay. Well, yeah, I know you weren't asking to me. Yeah, okay. That's better phrase. But the audio sounds good. Yeah. I've been doing good. Not much, not much. I've been doing good. Just chilling, trying to get behind with my
Okay.
classes, taking naps here and there.
Wait, Jose. Sorry. I messed up again. My audio wasn't working. Like an idiot.
No?
Okay, I'm good now. Thank you. Thank you to one of the best viewers in the whole world for telling me.
Really? I thought it was
Yeah.
working.
So maybe I shouldn't take your opinion.
Damn,
Because
bro.
clearly
Nah,
it's
I
not
think
valid. Clearly it's not valid.
you should double check my opinion.
I should, right?
Yeah,
Okay.
yeah.
That's alright.
Well,
We're better now.
thank you for the viewer that let us know.
Yeah.
Yeah,
We're better now.
appreciate it.
Anyways, Jose, sorry. What I was saying was, how have you been? What you been up to? What's one of your goals right now? Let me hear it.
I'm doing pretty good, just focusing on school, trying to get it through, battling the last few battles of school. Goal that I have right now is UFAS. I would say just focusing, like trying to prepare for a test, a data science test that I have. I want to prepare for that, study up, get all the research up and running, and yeah, I think that's the goal I have right now.
Mm-hmm.
What about you, brother?
Nice.
How's it going?
It's going good. I got a little sick over the weekend. Yeah, I think it was
Fuck, bro.
allergies. I think, but
You think,
um,
bro?
yeah, I don't know. We'll see.
Damn, bro.
But
And I
I
saw
got
you
over.
today, bro.
But like, it
Too
went. It passed
fast.
really quick though. Like that's why I'm a little bit confused. Like, why was it so quick? Like, it's kind of concerning. Like, usually I get sick. It lasts like a week or so, week and a half, right?
Oh, damn.
Yeah.
Yeah.
So that was a little weird. Anyways, so I'm sick, and then what else? What was the other question?
Goals.
Goals. Let me think.
Any projects that you have in mind? Anything like that?
Projects, goals, projects. Okay, one of my goals is I want to get. What I've been doing recently is like doing LeetCode problems, but like some problems that I solved before, and then translating them into Go. So I solved
Uh-huh.
them in Python before, but now I want to learn Go, so I'm like translating them into Go. So that's one of
Okay,
my
okay.
goals. Yeah.
Has that helped you?
Yeah, dude, it's really nice. Like at first, like it was hard because I was like I try to remember how to do an array because I don't use Go like often, right? And in classes we don't use
Mhm.
Go, right? So you really gotta put in the work in order to get proficient in it. And I was like, well, I've done projects in Go, and I know a general grasp of it and like the key things that are really good about it, but I haven't refreshed on it in a while. So I was like, how can I really refresh on it that's like not doing a project? So I said, you know
Yeah.
what, let me just do LeetCode, my old problems that I solved before, and then translate the Python into Go. So at first it was a little bit rough. Like I had to search a lot. Like how do you like? It might sound dumb, but how do you create an array in Go, or like just like the syntax? Like it was very choppy at first.
Yeah.
Then I got the hang of it, and then like some data structures, like I didn't know how to create, like maps. Like how do you create a hash map? Like I didn't know how to do that.
Yeah.
Or like what's in Go that's not in Python, what's in Python that's not in Go. So now like I'm able to recognize like, okay, I need to Python you do it this way, but in Go you're gonna have to do it a little bit differently. Does that make sense? So
Yeah.
it's been really nice though. Like I've learned a lot, and it was only been like a week and a half or so just doing that. So
Damn, bro. If you don't mind me asking, how often do you do it?
I try to do it daily. So I've been trying to do it daily. Yeah.
Okay.
Yeah, I was on like a 4-day streak.
Damn. Oh.
Where I'll do like a couple problems, 4-day streak, and then skip the day, did another one. But yeah, no, I think it's really efficient though. I will say, like, it's really efficient because like there are problems that you've done before and you like understand how you did it, but you need to translate it into a different language. So I think that's really cool. So
yeah.
But other than that, that's like one of my goals is just to get better with it, understand it, and stuff like that. So that's about it. Other than that,
bro. Nah, that's nice, man.
Yeah. Other than that, everyone who's joined, thank you for joining. We're gonna get started already. We have 579 subs out of 1,000 with our sub goal. We want to thank everyone that's been subscribing recently, been looking at our videos, our live streams. We do this weekly. Every week, I'm gonna show the screen right now. Let's see. Okay, we do this weekly. So, as you can see here, excluding 4 months, excluding like a gap of 4 months, we've been streaming every week, once a week. So, I think that's pretty cool. We're kind of in a rebrand right now, so content and thumbnails might not look the same, but the idea is still there. Like, we're trying to get better at problem solving every week, and we're very committed to this channel. We enjoy doing it. We enjoy helping others. We enjoy learning ourselves. Like, it's really fun. So, and also we try to cut our videos, we try to cut our live streams into videos. So that's what these are right here. We also had plans to do a couple of different types of streams. Those are still plans, but we're trying to figure out like how exactly, like production wise, like how to do it the best way. That's like one of our biggest challenges right now. So but we want to do some system design streams. We want to do some MVPs, like small mini projects that we can complete in one stream. So like it's just challenging, like how will me and Jose show our screens at the same time, or like how would the viewers like want to see it. So there's some things we have to think about, but other than that, that's about it. I think we're ready to start doing some problems. We got a couple problems here. The past 2 streams we've only been able to solve 2 problems, so this stream we really want to maximize the time and solve as much problems as we can. We have 4 problems in our list, and hopefully we get to solve all 4 of them. But with that said, anything else you want to say, Jose?
No, I'm doing good. I'm ready to start.
You ready? Okay, perfect. Let's see.
Oh, my hair looks crazy, bro.
I believe
Give me a second.
Okay, do your thing. Also, feel free to comment, by the way. Like, we're not scary at all. Like, feel free to comment. We enjoy the engagement. We enjoy the feedback. We enjoy any criticism. We thrive off criticism, right, Jose?
Yeah.
Be mean to us if you have to.
But not too mean though.
No, be mean.
Just
be extra mean.
Okay. Extra mean. Over exaggerate.
I'm just joking. Please don't be.
Yeah,
mean
no, for sure. Leave some comments on how to improve, what problems you wanna see. And one thing that we've been advocating a lot is for you guys to drop the problems in the comment section. That way we can, give your shout out first if we choose your problem, and we can solve it here, and you can solve it with us right here while we solve it live. But yeah, leave comments and yeah, talk in the chat, all that stuff. We'll be in the lookout and we'll see, and we'll give you a shout out. All right.
We're good. We're gonna.
Yes.
Also, oops. Let me move that. Wait. Give me 1 second. Let me switch this real quick. Let me get something open. All right, that looks good. How can I put this at? I'll put it right there. Okay, I think we're good now. Okay, perfect. So
Just.
to start this off, Jose, you want to read it? I read it. What do you want?
I can read it.
Okay, go.
All right. Yes. All right. This is problem 2574. Left and right sum differences. This is an easy problem, and it says the following: you're given a zero index integer array nums of size n. Define two arrays, left sum and right sum, where left sum of position I is the sum of elements to the left of the index I in the array of nums. If there is no such element, left sum I equals 0. Right sum is the sum of elements to the right of the index I in the array nums. If there's no such element, right sum I equals 0. Return an integer array answer of size n, where answer I will equal to left I minus right sum I. Example 1, we got nums 10, 4, 8, 3 as an input, and output of 15, 1, 11, 22. The array left sum is 0, 10, 14, 22, and the array right sum is 15, 11, 3, and 0. Example 2, in the explanation, the array left sum is this. The array answer is 0 minus 15, 10 minus 11, 14 minus 3, 22 minus 0, which equals the output that we got. Example 2, we use the input of nums 1, output of 0. The array left sum is 0, and the right sum is 0. The array answer is 0 minus 0, which equals 0.
All right, Jose. I wasn't listening at all.
Fast, bro. SMH. Rewind the live stream. Rewind. Go watch it again. Go watch the replay.
But okay.
No, I'll get, bro.
I'm gonna follow your lead.
I didn't really understand.
I'm gonna follow your lead, and while you're explaining, I'm gonna read it.
Okay.
Okay, I'm gonna follow your lead. Oh, also, sorry. Let me add you to this.
Oh, yes. Yeah. Let's see if it works.
There you go.
Working.
Perfect.
I think you.
Try it again.
I think. Did you share it to me?
Oh. Did I not share
there
it
you
to
go. Yeah. I just got it.
Who did I send it to?
I'm not sure.
Oh, I sent you a different link.
Yeah.
Okay.
And let me. Okay. Yes. Okay. To be honest, I didn't really understand it. I thought I did, but they lost me. So, I think. Okay. Define two arrays, left and sum. Okay, so we have to define two arrays, left sum and right sum. Left sum I is a sum of elements to the left of the index I in the array nums. Okay. Same thing for right sum. Return integer answer of size n, where I we equal to left sum I minus. Okay, let me see. Example 1. The array left sum is 0 for 15. Not sure. I'm not really getting it, this problem.
Where did it get 0 minus 15?
Yeah, that's what I'm trying to understand. Input nums 10 of size n to arrays that where I position I is some of the elements to the left of index
I see. Okay. So basically, you create these two arrays, and it's you get the left sum and the right sum. So you get the number, the array nums, and to calculate the left sum, you get all the numbers from the left of I. So if I is at 10, all the numbers to the left, you sum them all up. Since there's nothing, it's 0.
Okay,
4,
I see.
it's
Yeah,
10.
yeah, yeah,
And
yeah.
then 8, it's going to be 14. And then 3, it's going to be 22. Same for the right. So if it, yeah,
Okay.
you get it, right?
Yeah.
Okay.
Yeah,
So
I get
then-
it. Perfect.
You get the absolute value and subtract the left and right sum.
Yes.
Just. Okay, perfect.
Just.
So
Just.
let's see. So I guess the question is, should we do 2 loops to get the left sum and the right sum, or is there a way to do them at the same time? 2-pointer approach.
Let's think about that.
And you bring them inside. You have,
Okay. Let's think about this.
right? You have a left pointer, right pointer, and then you just
We can do that. Yeah.
But I guess you're technically still. Are you? No, I think you're doing both at the same time.
Okay.
There's also a recursive way to do this. It seems like a recursive
I see.
problem as well, or a
I see,
dynamic programming. What I meant.
I see how we're doing this. I think.
Okay, go. Go.
You see the left sum?
Yes.
How it's 0, 10, 14, 12, right? We go to position 0 and we measure out to the left, which is nothing, right?
Yep.
Now look at the right sum, 15, right? So we're getting the 15, which is the addition of all the right elements. So if you go to position 0, you go 4, 8, 12 plus 3, 15, right? You see how left sum is starting at position 10, is doing all the left. Right sum is just start position 0, index 0, and doing all the right. And then they get the first element. And then you go to 4, do the same thing.
So technically,
and that's how you get your number.
You just loop once, and you don't have to.
Yeah,
to loop
pretty
twice.
much.
Okay.
Yeah.
So we want to loop once and calculate left sum and right sum at the same time.
Yes.
Do you want to also subtract and do answer I?
Okay, we can do that. Yeah.
Maybe.
We can do that.
I think you can.
Yeah. Okay.
I think
Yeah,
so.
we can do that. Yeah. I believe so.
Okay, so just to kind of reiterate our thought process, if we're following my mouse wheel, my mouse cursor, this problem says you want to create 2 different arrays, right sum, left sum. Left sum will have the sum of elements to the left of the index I, meaning wherever I is at, you want to calculate the sum of all the numbers to the left of it. So if you're at if you're at 0, 1, 2, if you're at index 2, you calculate the sum of all the elements to the left of index 2, which is element 8, right? So that would be 4 plus 10, 14. And you assign that at left sum I, which is at 2. So then 14's at index 2. So basically you want to do that for all the positions in this array. That's basically what it's That's basically what the problem's asking for the viewers. Okay, so we're thinking instead of looping through to calculate left sum entirely, looping once 1, 2, 3, 4 to calculate left sum, and then do it again for right sum 1, 2, 3, 4. We could do it at the same time. We could say, let's start here. Let's calculate left sum by looking at all the way to the left, and let's calculate right sum by looking all the way to the right. And then you move again, calculate left sum all the way to the left, right sum all the way to the right, and then keep going, keep going, keep going. That's faster, I believe, instead of doing it twice. So that's kind of what me and Jose were thinking. Like, we can do it twice, and we could go this way and then the other way. But imagine if it's a large set of numbers or a large list. That's going to be very time consuming. You want to do it all at once if you can. Is that correct, Jose?
Yeah, I think if we do it with one loop, it'd be O of n. And if we do it with two loops, it'd be n squared. No, 2n.
2n.
Yeah.
Okay, so let's start it off. Let's start it off for I in nums. Hey, come on, focus, man. We got 4 problems to do. We can't be fooling around, okay?
Okay. My bad.
We're locked in.
My
We're
bad.
locked in right now.
We're locked in. Okay.
Okay. For I in nums, we're looping through the nums array. Now I is equal to the first element, and it will go all the way until the end. Okay.
I'm just trying to
What's up?
Ignore what I'm doing.
Okay.
Ignore what I'm doing. I'm just trying to do some stuff right here.
Okay. So now that we have I, we want to say calculate left, get the sum of all the elements to the left of I. But this format's not going to give us the index. This is going to give us the element. So we should say in range of len nums. That way we get the I is equal to the index. So we could say if I equals 0, and we create. All right, Jose, what did you put, man? Tell me.
Oh no. This is some brainstorming that I was doing here. We can use, I forgot what this is called, array partitioning, I think, or slicing. We can do some slicing. So for example, if we want to get the left, right, we can say nums. This empty space right here is gonna say, give me everything before I. So meaning the left. Here you can say it's gonna say give me everything after I all the way to the end. We can sum it up, both of them. The only thing, and then after this, do we need to?
Oh wait.
Yeah. Okay. Yeah. So this will probably give us our thing. The only thing, error or bug that we might run into is where I is 0.
Well, don't you worry, brother. I got you covered. We have a condition to where I is 0, and then we have another condition where I is equal to the length of nums. Or length minus 1. So if I equals nums minus 1, then we do that specific thing. So if it doesn't equal, then we do what you do. We do this. So we say left sum equals sum of nums I, and then right
Mhm.
sum equals sum nums I plus 1 to the end. I believe you got it right there.
I think so. Yeah.
Else, wait. Yes. Else, which means that I is equal to 0. Not equal to 0. Yes, which means it's equal to 0. Then we do that special case, which is left sum equals 0, basically. Left sum. Oh no, left sum stays the same. Right sum is still this.
Yeah. One thing I would say is that right here we're updating left sum and right sum. Okay, I see.
And left sum is
Okay,
always going to
yeah.
get initialized to 0 at the start. In this case, if I guess you could do this in the same thing. Else elif boom like this, and then else. So if I equals the end, right? Then left sum equals sum this, and right sum would equal the same. Yay?
Would it be? Wouldn't it be 0?
Oh.
Right sum equal to 0.
Right sum, yes, right sum is 0 right here already. Right?
But right sum, no, by right. Oh, okay, I see. Yeah. I get you. Yes.
Right?
Yeah.
And then we have a result array, and we say at the end of this, result.append abs, and then we say left sum minus right sum, and then is it math.labs or math.abs, or is it
Not
already
sure.
abs?
Let me see. Yeah, abs.
Is it append or is it
It's append.
Answer I.
Well, I think it's append.
Will we just keep on appending it, or do we have to put it in the exact location?
No, I think we just keep appending it because we have 0 minus 15, that becomes the first element. 10 minus 11, that becomes the second element. So I think it's the we just append it.
Okay.
All
So
right,
let's think it
ready?
through. Let's think it through again, one more time. So
Okay.
we loop through the index. We set these. We set left sum, right sum, initialize it to 0. We say if I is not 0, then you get. You gotta say if it's not 0 and I not equal to length nums minus 1, I believe. Because, yeah. And then this might be tricky. This is like, will this one pick up?
What do you mean? I don't think so.
If I was 0, Would this
It
run,
won't hit.
or would there be a chance that this runs? That's kind of my question.
Oh,
Because
well, if the length of no, okay. So for example, in example 2, the length is 1. Minus 1 that equals 0, right? Equals 0. Left sum of nums all the way to I. That's where the error or the bug I was talking about is that I'm not sure if nums colon I will give you, if you're at the edge of the array, I'm not sure it's just gonna give you 0 or something like that. I'm not sure if it's even gonna give you like a element in this case right here. Is essentially you're going before the bounds. It's like before the array. So it's like going to the beginning to I, right? But there's nothing there. So I'm not sure how that's gonna react.
Yeah, I think there's a lot of problems in this. Not a lot of problems.
We can run it and see. We can run it and see if there's any mess ups.
Yeah, I just think we just need to reword these if statements, because this work. I feel like this would work. You just need to catch it. So I think let's try to make it simpler real quick. Let's say if
you can switch the if statements, like check if it's a 0 first, and then if it's
here, take control real quick. I got a phone call.
Okay, bet.
All right. I'm back.
Oh, okay.
I'm sorry.
What I did, it was just add if statements here and here, right? So we can do if it's 0, do this, and if it's at the edge, do this. What we can do is that essentially this is capturing this. This is capturing this. We can move all of this into an else statement. That way we can get rid of this if statement.
Yeah.
So we can do some like this.
Or not
maybe?
even an else statement. You just say, or you tell me, and we can revert it back. But you just say if, and then if, and then this is just on, and then you just say continue, like continue, and then this is just normal.
Yeah, we can do that. Yeah.
Yay or nay?
Well, if we do continue here, we won't get here though. So.
So then you gotta move this inside.
Yeah, we gotta move this in here. Yeah. Oh. Yeah.
This is first of all, this is a 87.7%. We're noobs, man. Can't believe it. Are we thinking too much into this? Like,
I think
this might be it though.
Yeah, I mean, I think we understood the problem, but we're just trying to make it like look better syntactically, making sure we don't have those edge cases.
Yeah.
So, yeah. So I don't think we're noobs. We're just trying to, get it right at the first try.
Okay.
Yeah.
So we can
run it if we want. Yeah, we can. Yeah, let's run it.
Okay.
Let me see. Okay. Nice.
Okay. The second one works. Let's look at the constraints. So the smallest length is gonna be 1. So we're good on that. the number, the actual element number, the smallest gonna be 1. Okay. I think the test cases capture that edge case, if I'm not mistaken.
Yeah, I believe so too.
Right?
Yes.
Shall we
I'm
submit
just
it?
trying to look
Okay.
for test cases. I can't find any. Um, can we make some of our own though?
Yes. What would you want?
I'll like put two elements. And then another one with a bunch of elements. Yeah. Just like that. Yeah. I think
Okay.
that's good. That's good.
All right.
Yeah.
Done?
Let's run it.
Okay.
Yeah.
Nice.
Okay. Can you check if are we gonna have an empty array?
Yeah. So I looked at the constraints, and the smallest length will be 1.
Okay.
So
Yeah,
we
I
should
think
be
we can
fine on
submit
that.
it. Yeah.
All right. Submitted. Nice.
Oh, damn.
But why are we so far? Why are we so
I don't
far
know.
though? Let's go check. Oh, prefix sums.
Ah.
This person did. What? This might be a glitch.
Oh, I think that's a recursion. I think I'm not sure.
Ah. Maybe. I don't know. Okay, so prefix sums is clearly the fastest one. And they would basically they would get the sum of everything already, and then add or subtract based on that. Makes sense. Yeah, that's like,
Makes things. Yeah.
yeah.
Interesting.
So what we're
Okay,
doing
nice.
is each element we're going n to the left and then n to the right each time.
Oh, also, what this thing does is that it gets the sum every single time too.
Ah, yeah.
Yeah. It gets the
So,
sum every single time.
if we just calculate the sum in the total sum in the beginning and subtract the current index that you're on, you get the right one. And then same with the left.
Yeah.
Which that's very interesting. Yeah. I mean, we've done some prefix before in the past. But that was a good refresher looking at this code. Like I don't really
Yeah,
I
let
don't
me-
really
let me-
remember what it meant. But
Prefix 0 minus suffix. Suffix is. That is interesting.
yeah. Yeah, because
Because
prefix you
stuff
start at
made-
0 and you add the x.
Oh, okay. I see. Yeah. So you eliminate it,
Mm-hmm.
and then that becomes. Yeah, that seems fair. Yeah, that seems fair.
Yeah. All right. Well,
Okay, interesting, nice.
now we know. Did you want to explain it again? Do you have your little?
Oh yes, I forgot about that. Yeah.
Okay.
Yeah. I'll start it, and then if you want, I can start it.
Okay. Give me 1 second. Let me move this. All right.
Yes.
Go ahead.
Okay. What is it? Let me see. Let me refresh my memory. Okay.
Wait. Let's tell the stream what we're gonna do. All right, stream. We're about to get started on the next problem, but before we do, we're gonna quickly re-explain everything, but in a short form and quick span, like explanation. So we're not gonna drag it too long, but we just want to quickly explain it again for maybe just to reiterate, and then boom, we'll get ready to the next one. We have 3 more problems left. 3 more problems. So we solved the first one. Now let's explain it real quick, and then we'll do the next one. Okay, Jose.
Alright, so how we solved it, so In order to solve this problem, we used the for loop, we used slices, array slicing, and the mathematical functions of sum and absolute.
Yeah, this problem basically states if you have an array input nums, can you find the sum of all the left numbers at index I and the sum of all right numbers at index I, subtract them and get the absolute values of their subtraction, and then return that into another result array.
So our actual approach, we used like I said, we used a for loop that goes through all the different numbers, and from each of the numbers we get the index, and then we check if it's 0, right? We do what? We do two checks for two special cases. The first one being if I is 0, meaning we're in the first element, and if we're at the first element, the left sum or the left side sum is 0, right? Because there's no elements before the first element, so we leave left sum at 0. Then we slice, right, from the current position we are in all the way to the right, and we get the sum. After that, we append to res the left sum, which is 0, minus the right sum into res. The second case is when we're at the end. It's similar case when we're at the beginning, but now right sum is 0, right? Why would you say? Because after the last element there's nothing, meaning that we can add no more elements. So in this case we leave right sum equal to 0, and then we slice from the beginning all the way to I, we get the sum, and we append it to res. We have to take into consideration the absolute, because that's what we're being asked in the question. Lastly, if none of the edge special cases are hit, we get on line 25 and 26, for the left sum, we get all the left sum, we slice from the beginning all the way to the index, and from the index plus 1 all the way to the end to get the right sum. We subtract them, get the absolute value, and we append it to res. And some key takeaways is using slices, right? Slices are pretty awesome to move around the around the array, and they're really nice to get values. In this case, for example, the sum. So it's pretty nice to use and to understand how they work, because it can be really useful in managing and navigating through arrays.
My key takeaway is this is almost like a brute force approach, but we, instead of looping once one way and then once the other way to get the left and right sum, we decided how about we just loop through the array once but calculate the left sum and right sum at the same time. In our heads we're thinking we're going to be saving compute power, but after submitting and reviewing some other submissions, we noticed that might have not been the best approach. So a good key takeaway is that using suffix and prefixes to calculate the sum beforehand and simply just subtracting the current element at I is a far better approach in order to solve this problem compute-wise. So I think that was a good insight for sure. Is in a problem like this, if you're trying to calculate sums, you should definitely look into prefix or suffix, just in case. That might be a better approach rather than what we decided to do, which was each element that we're currently on, we go n times all the way into the beginning of the array, and then n times all the way to the end of the array to calculate the sums of the left and right. So those would be my key takeaways. And that's it. Good stuff, Jose. All right.
Yep.
Next problem. Enough with that.
Yes.
Oh wait, sorry. Gotta do a clap for that one.
Oh yeah. The animation.
Yeah. We forget about the claps. Do some little celebrations in the chat. Okay. Next, where are we at? Next problem. Let's see. Let's turn off this one. And this. Okay. Let's go to the next one. not that. This one. Nope, not that one. Nope, not that one. Nope. This one. Okay. Score string. Let me add you. Invite. Boom. Alright, how's that? So I can read this one if you need me to.
All right, bet.
Whenever you're ready, man.
I'm good, brother.
All right. Are you in the?
Yes.
Okay.
I am.
Okay. So this problem, it's called score of the string. It's problem 3110, and you're given a string S. The score of a string is defined as a sum of the absolute difference between the ASCII values of adjacent characters. Return the score of S. Okay, so for example 1, we have the input S, which is the string hello. The output is 13. The explanation for this is because the ASCII values of the characters in S are H, which is 104, E, which is 101, L, which is 108, and O, which is 111. So the score of S would be 104 minus 101 plus 101 minus 108 plus 108 minus 108 plus 108 minus 111, which will equal to 3 plus 7 plus 0 plus 3 plus 3 equals 13. Okay, so for example 2, similar thing. We have input S, which is a string that says Zaz or ZAZ. The output would be 50. Why? Because the ASCII values of the characters in S are Z, which is 122, and A, which is 97. So the score of S would be 122, which is Z, minus 97, which is A, plus 97 minus 122, which is A minus Z, which means it's 25 plus 25, which equals 50. So the constraints say the s.length will not be less than 2, and it will not be greater than 100. And it will only consist of lowercase English letters. You got that, Jose?
I got that.
Okay. So to put the problem in our own words, you're basically saying get the ASCII values of all the characters and just simply subtract the character after it until you reach the end.
Mm-hmm.
Basically what it's saying.
Yes.
Perfect. ASCII characters in Python, and I believe in a lot of other languages, are really easy to get. There's already methods that calculate it for us. For Python, it's ORD. I don't know what ORD means. What is ORD? Like, what is...
Not sure.
Ordinary? Like, I don't know what ORD means. But ORD will basically get the ASCII value of any character. And I believe it only... You get an error if you do like if you say let me see, character
well, let me see.
Can you get a error if you do like this? Print.
Pretty sure, no?
Right? Like, that's not a character, that's like... Alright, perfect. So
Yeah.
ORD is expecting a character which is the length of 1. Since this is the length of 2, it will give you an error. So now since we only have the length of 1, we should get the ASCII value of H, which is 104. Alright, so that's basically that function ORD there. So now that we kind of explained that, I mean, I guess you could just loop through the string,
yeah,
and then subtract as you go, right? So, yeah, you're nay. Like you have equals 0 or... Oh no, you're subtracting, getting the absolute, and adding to res or whatever, to like a counter. Yay?
Yeah.
So we want to loop through S and calculate abs of I plus 1 Wait, no, minus I plus 1. And then add to res. Does that sound about right?
Yeah, that sounds about right.
Okay, I'm gonna let you type it out, man.
All right.
I'm gonna blow my nose.
Bet. I got you. Like that. So we're gonna do cur, which equals to the absolute of the order of position I minus, if I'm not mistaken, ord si plus 1. And why not? Let's just do res. Oh, that's the wrong button. Okay. Whoa. Okay, there we go. That. What do you think about this?
I think that's good. S minus 1, I plus 1. Would there be a chance you get an error right there? I know you.
Where?
On the
Here?
I plus 1.
Well, that's why I did a -1. So we end the character earlier, or one before the last one.
But wouldn't length S already be like counting length S minus 1? Oh, okay, I see what you're saying. Because in range already isn't inclusive; it's exclusive. In range stops already at the end. No, hold on.
Yeah, range stops at the end, 0 to all the way to the end. So you do -1, so you do 0 and -1.
Yes. Okay. I think that's right.
I think this work. I can run it my end.
I could
if you
run
want
it
me to.
just so it could show like the
Okay.
the viewers. Let's see.
Nice.
Nice. Is there a test?
All right, let's put a bunch of letters.
Let's do this. ZZ.
That's me right now. Sleepy.
Sleepy. I think that's already good. I think that's good.
Yeah?
Yeah.
Okay, we can submit it then.
All right. Beautiful.
Oh, nice. It's 100%. Nice.
Amazing. Oh, hit the yay. Let's go.
Yay!
All right. So that was easy. That was actually really easy. What is it?
Yeah, that was pretty straightforward.
Wait, what time do we usually in stream? I forgot.
10.
10. Okay. All right. So now let's explain it. I guess. I mean, there's not really much to say. Like.
Yeah.
So I guess. Let's just get started on it. That wasn't really a challenge at all. At least we got it out the way.
Okay. We got it out the way.
All right.
It was a nice.
That means
a
we're
nice
able
problem.
to explain this really well, Jose.
Ooh, fast.
All right.
Okay.
Go ahead.
You want me to start? Okay.
Oh, I could start.
Okay, yeah.
ready?
You start because I started before. Yeah.
Give me 1 second. Let me zoom in a little bit. All right, ready?
Mm-hmm.
So Jose and I solved this problem by using a for loop that will go all the way to the length of s minus 1, and we basically want to get the ASCII characters by using the OR function and getting the absolute value of that, and then you incrementally add it to res and you return res. Wait, Jose, I basically said the whole answer. Let me retry.
Go.
Retry.
Okay, we can retry.
Okay, sorry. Retry. Okay. So me and Jose solved this by using a for loop and incrementation logic, and then we return res at the end.
So pretty much this problem is asking us to get the score of a string based on the ASCII values of the characters inside the string. For example, in example 1, we get hello, right? And the explanation, we're given the ASCII tables of each of the characters found in the string hello. And in order to get the score of the string, we have to get the current character we are in and the next character we're the next character after us. We have to get both of the ASCII tables, subtract them, get the absolute value, and add it to the next batch of characters.
So in our actual approach, we use a for loop, and we wanted in the for loop we wanted to calculate the absolute value of I minus I plus 1, and then we add that result to res, which is our result. The trick here though is that since we're doing I plus 1, since we're doing I minus I plus 1, that if we originally had the for loop going all the way to the length of s, in range of length of s, there would have been an edge case or an error at the end that would have said that would have been out of bounds. So that's why we decided to use -1, so that we could stop the character before the last character, because if we want to add s I plus 1, that we won't get that error. So after doing that, we return res and we get the correct answer, which shows right here, and that's our result. Key takeaway for this one was just remembering that if you're going to do logic that is I plus 1 or anything like that, you want to get the element ahead of the current element. Just want to make sure that there won't be no out of bounds errors possibly, because those are very important that people might overlook.
Yeah, just like Carlos said, I feel like doing that -1, it's very critical. Because like Carlos said again, people might just overlook it at it and break their heads of like, hey, why are we out of bounds when this and this and that? So remembering how array works and all that stuff is really nice, just a refresher. And so yeah.
Nice. Woo!
Nice. Man was about to do the entire explanation. He was gonna leave me with my own takeaway at the end, and that's all. He was gonna do my own takeaway.
All right, next one, dude. Next one.
Okay.
Next.
What is the next one? I forgot.
Range of
Oh, I remember this one.
Binary search tree. Oofas.
Okay.
Here. Let me take the lead real quick. I'm really cold. I need to turn off something. Oh. Yes. Give me 1 second. And add, create link, invite, boom, boom. Alright, be right back. 2 seconds.
Range low high. Okay, it's very interesting, very nice. So for example, in example 1, we're given the binary tree of 10, 5, 15, 3, 7, 18, and a low high of 7 and a high of 15, and the output is 32. Explanation is that nodes 7, 10, 15 are in the range of 7, 15, so we add 7, 10, and 15, which equals 32. Example 2, we're giving the root of 10, 5, 15, 3, 7, 13, 18, 1, and 6 with a low of 6 with a high of 10. Explanation says that nodes 6 and 7 and 10 are in the range of 6 and 10. And therefore, the sum of all nodes 6 plus 7 and 10 is 23, and therefore that is our answer. All right, all right.
What?
Yay or nay? Yay or nay?
Okay. I think I get it.
Do you get it? All right.
Yeah.
Bet.
So they don't have to be they don't have to be connected, right? So can
No,
there be like an 8 over here, where 18's at, where node 18? Could there be an 8, and would that be counted as a node that's in the range?
well, it's a binary search tree, so left side is always gonna be less than the right side.
Wow. You really called me out there. Yeah, you're totally right. Yes.
Yeah. So yeah, pretty much.
Okay. So basically, if the high is 15, then you do everything on the left. Like you find 15 or you find that high, and you do everything on the left.
I'm not sure if the value, if the values in the range are gonna be necessarily in the binary tree.
Yeah.
Yeah, I'm not sure because I'm not sure if it specifies them.
But you want to just find all the values that are in the binary tree that are in the range.
Yes.
But there's not going to be, like for this one, there's not going to be 7, 8, 9 in the list. Like, it's going to just be 7 and 10. Oh no, 6, 7, and 10.
Yeah.
With the low 6 and a high 10.
Yes, but I do think that they're gonna be in the binary tree because the range might be, it's inclusive.
Yes,
So,
the low and high are going to be inclusive. So
yeah.
that means those are always going to be in the tree.
I'm not sure though, because we might have the high but not the low. You know what I'm saying? This one is a good one. I like this one.
Okay. So we basically say, basically we start at node. If node is less than high, if node val, if it's less than high,
Less than or equal to.
less than. No, I say if it's not equal to high, and if it's less than, then don't we go to the right to go find high? Or you add it to the list and you go find high? Or, like, my point is like, you're gonna have to reverse back, no?
Well, we can traverse the array. We can traverse the tree, right? Might be a brute force. You can check each of the nodes and check which ones fit in their range, right?
Oh, yeah.
Yeah.
Well, I think that's one of the. Keep going. Sorry.
Yeah, pretty much.
Yeah, because if you, I need to blow my nose.
Yes. No worries. But yeah, so yeah.
I think you're right
The
because
node.
if the node that we start off at is in the middle of the range, then you're gonna have to go left and right to find all the nodes anyways.
Yeah.
But of course there's a bit more optimized way, which is like if you find the lowest range, like if you start on the left, you go on the left tree only. You start on the left side, you find the low. Once you find it, you don't go any more lower, because you know there's not gonna be, all the rest are not in the range. And then you reset, you go back to the top, and you go all the way to the right again from the top until you find the high, and then you stop. What we're doing right now is we're saying let's just iterate through everything, and then just add those to the list. Add the ones in the range to the list, which is like less,
And
which is bad because we're gonna loop through the entire. Because what happens if all the range, like they have a big tree,
well,
and the range is only on the right side, but our algorithm is going all the way down the left, and then the left side is like so large, and then all that to find out that all of them are on the right side.
that's why I wanted to do a check if the
the
node
beginning?
that we're looking at is less or bigger, right? So let's say, for example, 5 is less, right? So it's 5. Yeah, it is interesting. Because I do like your approach, finding this, like the low and the low bound and the upper bound, right? But while we traverse, are we gonna be adding it to something? Or are we just gonna find it at 7 and then find the 10 and then traverse it again to add all the values?
Yeah, you're you're adding them to you're adding them to something.
Okay. Do you think it'd be possible to do it in one try? Like in one traversal?
But like efficiently in one traversal? Like not like searching through everything? Yeah, using recursion, right?
Yeah. Do you think this is an Excalibur problem?
Let me look.
I'll follow you lead. I trust you. I'll follow you lead.
I think. You know what? Okay, look at
No,
my
I follow
mouse.
your lead.
Look at my mouse. Look at my
I
mouse.
follow your
Ready?
lead.
Ready?
Yes.
Okay. Right here, like you said, we start off at 10. Is that in the range? Yes. Okay, go to the left. Is this in the range? No, it's not. Okay, boom. Wait. Okay, no, it's not. Let's go to the right, if there's a right, because it's going to be higher. Higher than 5, less than 10. And we know that the high is 15, so we know that it could still be here. So then you go to the right, and then boom, 7. Is there any more children? No, there's not. Okay, boom. Go all the way back to the top. So we break. Once there's no more children, and once there's no more children, or the left or right are not in the range, then you just reset and go back to the top. You break or something, and then we have 2 other functions, right? We have a left traversal and then right traversal. So left traversal is done, and then the right traversal is now starting, and then we do the same thing there. And you stop instead of traversing through everything.
Okay.
Yay.
Yay. Okay. I'll follow you lead.
Okay. So we say, should we do these outside? right? Or no? No, it needs to be
You can
inside,
do it
right?
either or. You can do be either or, I think.
You think so?
Yeah.
We say if roots. Oh. If root dot val less than equal to no. So we're basically the first thing we want to say is
Cool question. How are you gonna start it though? Like left or right?
I was just thinking left.
Okay. Okay.
Okay, if root dot left. Oh, if root dot left, then root. You say if root dot left dot val is, and we know this is the less one. So is it if it's greater than low, then you want to add node to sum or whatever sum. Okay.
Isn't it equal to, no?
If it's equal to it, then that's when we want to add to sum and then stop the traversal. Because we know whatever's remaining, left or right, like.
Yeah, I see it. Yes.
Or if it's no, you don't want to stop it because let's say low was 5, right? You have 5, but there's still 7 in the list. So you wouldn't want to stop it. You would want to say
There's also 3. If it's low. Yeah. Interesting.
if it was 5 and it's equal to it, then you add it and you check the children.
You have to. If it's 5 and it's equal to it, you have to traverse the left.
So if that's a low.
If 5 is a low, you have to traverse the
right.
left. If it's low.
If 5's the lowest, you can't go to the left because it's gonna be lower.
Oh
than 5.
yes. The right. Yeah, my bad. Yes, the right. Yes. That's on me then.
In this case, you go. If you traverse to 5 and that's outside of the low, then that means the only way to go is right. So if the node you're on, if it's greater than equal to low. No, if it's greater than low, then add it to the sum, and then you're still gonna look
left and right.
At the left and right. If it's greater than low, add to sum, still loop left and right. If it's less than low, yes.
Okay, I'm not sure, but do we really need two functions for the traversal?
I was just thinking 2 functions because how would we stop the left side to reset all the way back to the top? I was thinking, well, how do we stop it here?
Oh, you're not doing recursion, right?
I don't think so.
Okay. Got you.
But at the same time, I think I am.
It's because if you're a little bit, because if that's the case, Yeah, I think you have to do recursion to traverse the tree. Because I don't think we can use like a for loop or something like that.
Yeah.
Well,
Oh, wait. You can say while root dot left. That might be the move. And you just have an extra condition. Like if while root dot left dot val greater than low, add to sum, and then you say root equals. Nah.
Yeah, because then you're gonna lose the reference.
Well, in that case,
You
how
have
about we
to
just
update.
loop through the whole thing? How about we just iterate through all the nodes? That we just start off there. I think if it's not as clear as we thought it would be, like I'd rather just.
No, it's because you're onto something. I feel like you're onto something. I see where you're going, and I think you have something nice.
And I agree, but I just think that with the time we have, I'd rather just solve it.
Okay, bet.
That's my only thing.
Yeah. Okay. I'll follow your lead, brother.
Okay.
Follow your lead.
Okay.
Whatever route you
So
want to take, I'm there for you.
Let's get out of that solution. That might be a better solution, but with the time we have, we're just gonna do a normal traversal. Since this is a tree, we want to do a normal traversal and look at all the nodes and add the nodes that are in the range. So loop through entire tree, add nodes to sum if in range, return sum. And maybe we're overthinking it. It is a binary search tree. It is a range problem. Just based off the wording here, I feel like there's a way easier approach than just traversing through everything. There's definitely like a math solution that's like, oh, obviously if the start is 10 and the low is this and that, then all you need is like, I think there is a better way than those two approaches. I think there is, because it just makes sense to me. If they're making it a binary search tree or binary, they're making it a binary search tree. Like there should be like a trick to it that will make it really solvable.
Yeah, I agree with you.
But I'm not catching it right now. I don't know. It's not making clear. So we're gonna do pre-order traversal.
Yeah, we can do that.
Pre-order. I forgot how it was. Root.
Fast. Pre-order is. Yeah, if root dot left. So we hit the root dot left. Yeah, we're gonna go all the way left. Then
it goes. Wait. Something like this. Root dot left equals.
Let me see.
If not root.
Oh
man, I forgot.
I think it's return.
Okay.
Then
pre-order. Beautiful, brilliant. Yeah.
Left.
But
before that, we have to process the root value.
Yeah.
So.
If do your thing.
Let's create a. If. Is. What is it? Greater than. Oh my god. Greater than or equal to low. And or. No, and. Your day.
Yes.
And then here. Yeah, you go root dot val. There, I think so. I think so.
I think that's brilliant. And then
Mm-hmm.
we say
Yes. Oh, fast. What we got? Oh, because it's being referenced outside. I see. This?
yeah.
Oh, we have to pass
Oh.
in res.
Oh yes. But also we say if root left, no?
Oh, yes, 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 yes. Oh, my bad. I'll let you do it. I'll let you do it. Mm-hmm.
Oof.
Go fast.
Okay.
Mm-hmm. Interesting.
Oh, I know what we did last time.
Okay.
I think. Don't laugh
So our
at me.
code got into. No, our code made it there. So you're doing something good.
Okay. Dude, you saw how long it took?
Yeah.
Oh, let me blow my nose again.
Okay.
Alright.
There's just cases on the discussion, like on the first tab.
Okay, let me see. Oh,
Yep,
nice.
right there.
Oh, wow. Okay. Dude, I don't know if ours will pass. Oh, wow. Okay.
Have some faith, brother. Have some faith. Have
It
some
did.
faith.
No, I was just saying, like, it might take too long.
Yeah.
But, alright, do we
I
submit?
can submit it. I can submit it on
No,
my end.
it's okay, dude. We gotta take the
Okay.
penalty.
Okay.
Submitted.
Closing mine.
Nice.
Oh, let's go.
Okay, so clearly, yeah, clearly we knew this wasn't the best solution.
Do you want to see the best solution? See
Yeah,
how
let's go see what
it
they
did
did.
it? Because I think you were on the right track. So num0 returns 0. If it's greater than low and root is high, okay, you add it, yeah. If it's low, do num plus self range PST, so you're gonna use the same little thing. We're gonna go to the left, low and high. If root val is low, greater than low. Okay.
Then you go to the left.
I got low.
So if we're over here, if we look at our code, I mean, look
Yeah.
at the example. Greater than equal to low, then you add this to the thing, and then if you add it, and then what happens?
You continue to the next if loop.
If root dot is greater than low, which it is, num plus equals self dot range root dot left, and then is that greater than low or high? It is less than. So it'll be here. So you say root.right, and then you add it, and then it takes you back here, and then it's less than high. Wait, so does it do that again, or am I dumb? You're here, takes you back.
That was low.
And then now you're back to the top, which you should be here. Yeah, I mean that's recursive.
Yeah. So I think what they're doing here is if you're greater than low, right? We want to see how far you can go, how close you can get to low. You know what I'm saying? So for example, 10 is greater than low, which is low is 7. So you go to 5. 5 is low, right? So you go to 3. 3 doesn't fit the first if statement, the second statement, or the third if statement, so you return 0. Right? So you go back to 5, and then you go to 7, right? And then you do the same thing on 7, but 10, right? So you go to 10, check how far the left side of 10 can get close to low, and then on the right side it says, okay, how close you can get to high, if that makes sense. So it explores the right side of the tree until it hits a point where there's no 0.
Yes. But the side note, I also still don't think this is the best approach, because unless I was tracing it wrong, it does a duplicate. So if you're at 5, right, and you're recursively in the trace right now, you're at 5 and it's greater than low, it's not, right? So then you go here and you check the right of it, and then you start here. So it's 7. Yep, you add it to 7. And then is it greater than low? Then you check. That's not. So then now you go back to this one, less than high. Check the right, there's nothing. Now you're back at 5, and I might have chased it wrong actually. Woo!
Yeah, so
because I thought it went 10, 5 to 7, back to 5, back to 7, and then back to the top. I thought it traced like that, and I still kind of think it. I just didn't explain it right. I don't know. I don't want to look at it again.
You know, we're looking at it. Okay, bet. We can stop it here.
I mean, I don't know. Maybe I'm just delusional. I thought it did it again.
Goes. Yeah. Okay. I see where you're coming from, because it goes to 5, right? Like you said, 5, and then it goes to the left, right, and checks if 3 is less than blah 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 blah.
No, it doesn't go to the left.
No. Yes.
Where?
It goes to on the second if loop, second if statement.
It's not greater than low.
Okay, so it's not greater than low, right? So in that case, we go back to 7. Right. 7 says, all right, this and that, right? Okay, so we still on 5, right? 5, it skips the low. We go to 5. We go to the right side.
Yep,
so
7.
right 7 starts from the beginning,
starts
from
here.
num 0. Yeah, right
Adds
there.
it.
We do all that.
Greater than low. Is it?
Right. Greater than low? No, because it's 7 is 7, so it doesn't do this, right? Root less than high.
It is.
Which it is.
But
right, we
no
go
child,
to the right side.
So it
there's no right child, so we stop and we come back to this. And remember, 5, we're still on the right side.
5 was right here.
Right, we're still on the third one. Yeah, 5 was there. So once we finish with 7, 5 continues there,
and then 5
and then goes
done.
to return, and
Back
then
to
it goes
10.
to return num, and then it goes to 10.
Which 10
and
goes
10
right here.
finished. Yeah, exactly. Yeah.
Okay, so it doesn't duplicate. Okay, I thought it
Yeah.
duplicated. My mistake. All right, Jose.
Yeah, it's a little bit weird. Yeah, that solution is weird. I don't like it when they use the function like this one range sum BST. I don't
Uh-huh.
really like it when
Oh
they
yeah, those
use
are a
it.
little tough. Those are tough to trace.
Yeah. All right,
Um,
brother. Dude,
wait, we
this
gotta
problem I
explain.
like this
We
problem.
gotta explain.
Oh yes. Yeah.
What's up?
If you want. Ooh.
What's up,
Hey,
AS?
easy.
What's up, AS? How you doing? AS said easy, bro. Yeah, I mean,
Yeah.
it is. It was definitely a refresher for me, I would say.
Yeah, for me too, brother. For me too.
But okay, let's explain it real quick. Let's re-explain
Yeah.
it. You know, let's bring it back together. Um, what do you think? You think? Yeah, I think it was.
Yeah, we can do this. Okay,
Yeah.
okay. Yeah. If you want, I can start it.
Okay,
'Cause you
go
started
ahead.
the last one. Okay. So, how do we solve this problem? We used pre-order traversal to traverse the entire tree and find and get the values of each of the nodes.
The problem basically states if you have a BST, a binary search tree, and you have a range, an exclusive range from low to high, sum up the values of all the nodes that are within that range. So the trick is that it's a BST, so we all know that at the starting node, which is 10, all the nodes to the left of it will be less than 10, and all the nodes to the right of it will be greater than 10.
Yeah, so our initial approach was that we wanted to figure out a way where we can filter out the values that are less than low or higher than high. Uh, but that didn't really give, we couldn't really like map it out in our brains. And due to time, we decided to go to another approach.
So the actual approach we decided was a brute force. Jose, why are you laughing, dude? Jose, stop laughing. Okay, reset. I never reset my part. Reset. Jose, why are you laughing, dude? Stop. You're making me laugh.
Okay. Reset.
Okay,
From the
reset.
top?
No, not from the top. I got it right here.
Okay.
So, so our actual approach was by, I guess it's technically brute force approach, which was traversing pre-order through all the nodes and then just seeing if each node's value is within the range. As you can see here, we defined a function called pre-order. We input the root and the result value in there. From there, just a normal pre-order algorithm, which says if you're actually on a valid route. If not, you return nothing. If you are, you check to see if it's the root value is within range. And then from there, you check to see if that root has a left child or a right child. If it does, you basically recall the pre-order function and going to the left, and you call the other pre-order function going to the right. Of course, you're passing the value result through those as well, so you can keep track of the counter. And from there, you just return the result sum. And I would say the key takeaway is of course, like for us, we want to, since we do these live, we wanted to stay within the time frame. So the key takeaway was, I personally was thinking like, let's try to find the best approach, but sometimes you should probably start off with the brute force approach if you're not truly understanding what the best approach might be, because you could really overthink the solution on the approach you want to do, and then you're just wasting a lot of time. And just start off with the brute force approach, and then from there you could possibly see where you can improve it, just so you can save some time. Maybe it's like in an interview or something like that. I think that would be most beneficial. So because for me right now, I was definitely honed in on a certain approach that was kind of like the most efficient, but clearly I wasn't really understanding it, so we just decided to do the brute force approach.
Yeah, similar to what Carlos was saying. During this we're in trying to figure out like the best solution and trying to use the nature of a BST, which is that on the left side there are the low values, then on the right side are the high values. We kind of got wrapped in all this like confusion. We didn't really know how to best approach it, and I think we had a solution in our minds. Especially Carlos. Carlos had a solution in his mind that I think it would have worked out. But I think we kind of, we started in the wrong place, and we looked at it the wrong place that we couldn't really put it into life. So that's why we resorted back into the binary search tree just to get a little bit of fresher understanding of how they work and stuff. But for sure, trying to my main takeaway is that sometimes it's better to analyze it, see how it works, see the conditions, probably do a little bit hand drawing or something like that in order to get a better picture, and then move on to the code. Or just do the brute force ways, and then from there you just modify it so you can get the best answer possible.
Perfect, Jose. Comment below which questions you want us to solve in our next stream. Let's go. Clap it up.
Hey!
All right, good stuff.
Let's go. Awesome.
All
We're
right.
one step away from 580 subscribers. So make sure to sub, leave a like, share, comment, all that stuff, all that good deal. Cause we want to get to 1,000 subscribers. 1,000 subscribers. That's a new goal. It's an ambitious goal, but we're getting there. Like always, we're gonna be here every week. From Wednesday from 8:30 to 10. But yeah.
I think that's about it.
Yeah.
Good stream. I think
Nice stream.
we solved 3 problems, so that's always good. Not a lot of chatter this stream. That's okay. There's gonna be ups and downs.
It happens.
We're still gonna be here every week, whether there's people here or not. I think it's a good refresher for me and Jose. So that's about it. What else, Jose? Anything? I think next stream we might possibly have a new stream theme format.
Yeah.
We might introduce a new one of our new ideas for our streams next stream. But we're just gonna double check. There might be a last minute change. It might end up just being a video or something like that. So we're still trying to figure that out. But
yeah.
Other than that, I think that was pretty good, dude. I got refreshed on a lot of little stuff.
Yeah, no, pretty exciting. It was exciting live stream. We covered arrays, prefixes, suffixes, trees, and we solved 3 problems. So which is pretty nice, pretty cool. And yeah, it was a pretty nice stream. I enjoyed it a lot.
All right. I think then that would be it then. I think that's about it.
Alrighty.
I'm gonna go finish up some homework and then get on Battlefield 6.
Baby, bro. Let me know how that goes, dude. I'm excited for that game, dude. Looks fun.
It's gonna go extremely well, man. Extremely well.
Alright, bet.
Alright, Jose. Until next time, until next week.
Alright.
Good chatting it up with you. Good talking it out. I'll see you around, alright? Everyone in the stream, thank you for joining.